Hello class, welcome to this lesson on 4.5. We're going to be talking about solving rational equations. So we want to be able to solve rational equations as well as identify extraneous solutions. And in doing so, we're going to have to identify restrictions to the domain. So we want to know what a rational equation is as well as what an extraneous solution is. So a rational equation is an equation that contains a rational expression. So, in solving a rational equation, these are the following steps that you need to follow. So, in order to be able to solve rational equations for this step-by-step process, you'll need to know how to find the least common denominator of all fractions involved, and you'll need to know how to add or subtract fractions on each side. So this would be the lesson, this would be in the previous lesson, which would be 4.4. So if you don't know how to add or subtract fractions or find the least common denominator or anything like that, make sure you go to that previous lesson. So in doing steps 1 and 2, once you're adding and subtracting fractions on each side and finding the least common denominator, you're going to multiply both sides by the least common denominator and simplify and solve for x. And that takes care of solving. Step 5 involves finding restrictions for x in order to check to make sure that each solution that you got from step 4 is correct and that they're not extraneous solutions. So we're going to talk about finding the restrictions to the domain and as well as solving the rational equations. So let's look at step 1. Well, first, in order to solve this, you're going to, using the steps, we're going to put this over 1. So now we got a fraction equals a fraction, and for step 1, we're going to find the least common denominator. Well, the only factors here are x plus 4 and 1. So therefore, my least common denominator is simply x plus 4 times 1, which is just x plus 4. So step 2 is to be able to add the two fractions, or be able to basically combine any fractions that we see. In this case, we can't combine any fractions. So we're going to leave it as is. So we're going to skip step 2 because there's no addition or subtraction of fractions on either side. Now step 3, you want to multiply both sides by the LCD, right? So we're going to do that here for step 3. Well, the LCD is x plus 4, so we're going to times x plus 4 on both sides. And doing so, we cancel out the x plus 4 on the left side. So we have 1 equals 2 times x plus 4. And then step 4, we will have to solve. So we have 1 equals, we're going to have to distribute this 2. So we get 2x plus 8. Then we're going to solve. So we're going to subtract 8 on both sides. We get negative 7 equals 2x. We're going to divide both sides by 2. We get x equals negative 7 over 2, which is negative 3.5. But we can leave it as a fraction. We don't have to do anything to it. And that's our answer. Now, we'll have to figure out restrictions to our domain. So let's show you how to do that. This is step 5. So restrictions to our domain. Something is a restriction to a rational equation if you figure out an x value that makes any of the denominators 0. So if you look at this first denominator here, you cannot have that denominator equaling 0. So what we're going to do is we're going to say that x plus 4, that denominator, cannot equal 0. And the reason is you get undefined if you have a fraction equal to 0. So you cannot divide by 0. So in this case, if you had 1 divided by 0, that cannot happen, right? So that would be undefined. So therefore, we're restricted to that, to not being 0. So we're going to go ahead and subtract 4 on both sides. And we're going to get x does not equal to negative 4. So x cannot equal to negative 4 is our restriction. In this case, that does not equal to this guy. So that means that this is not an extraneous solution. So in this case, we have no extraneous solutions. An extraneous solution is a solution that you get upon solving but that doesn't make sense when you plug it back into the original equation. So that's what an extraneous solution is. So in this case, it doesn't make sense. If we were to have -4 as a solution, it wouldn't make sense to plug that into the original because we'll get 0 in the denominator. However, because the solution that we found does not match the restriction, this means we have no extraneous solutions, which is a good thing, which means that this is our final solution. So right here is our final solution. If this solution matched the restriction, then that means that there would be no solutions at all. So let's look at the next part, and maybe it'll make more sense upon another practice. So step 1, again, we're going to find the least common denominator. Now this is already, you can't do anything to this x minus 3. You can't factor it or pull anything out. Now this one you can't factor or pull anything out either, so we're going to leave it as is. So therefore our LCD is simply those two denominators combined, since they're both unique factors, and the most of each factor would be equal to 1 of each. So now step 2, notice that step 2 we're going to skip as well, because step 2 involves adding or subtracting fractions, which is not involved in this equation. Now step 3, which I'll write here, involves converting the fractions so that they have the same denominator, namely the least common denominator. So notice that this x minus 3 is missing an x plus 16. So we're going to give it an x plus 16. Oh, actually, we're going to skip that step. I apologize, because we said that we were going to skip that step. So the next step, which is step 3, is to multiply both sides by the least common denominator. So we're going to go ahead and multiply both sides by the least common denominator. In this case, that will be, and I'll write it here, we'll multiply by x minus 3, x plus 16. So ignore what I said before. So multiply both sides by least common denominator. In doing so, notice that the x minus 3's cancel and the x plus 16's cancel on the right side. So we'll have left over, we'll have 1 times x plus 16, which is just x plus 16, equals, then we'll have 5x times x minus 3. We'll have to go ahead and distribute this. So we have x plus 16 equals 5x times x is 5x squared. 5x times negative 3 is negative 15x. Notice this is a quadratic equation because of the 2 here. So because it's quadratic, we're going to have to set one side equal to 0, which means we'll have to move everything to one side. So I'm going to go ahead and move this x over to the right hand side by getting rid of it and subtracting it on the left side. I'm going to subtract the 16 as well to get rid of it, but I have to do the same thing on the other side as well. So on the left side now I have 0. I can bring down the 5x squared. I can combine the negative 15 and the negative 1 here to make negative 16x, and then I can bring down the negative 16. So now I have a nice looking quadratic equation which I can solve. So what I'm going to have to do is, notice that there's a 5 here, so I can factor this, or I can use quadratic method, the quadratic formula. I'm going to go ahead and look at factoring this so I can show you the AC method. So we have an A and we have a C, so we can multiply those two together, and that's known as AC method. So we're going to try to multiply 5 and 16 together. Well, 5 times negative 16 is negative, in this case is negative 80. And then I'm going to find the factors of negative 80 that add up to negative 16. So if I did 2 and 40, that wouldn't work out very well. If I did 1 and 80, that wouldn't work out very well. And if I did 4 and 20, that would actually work out better. And it would have to be negative 20, because negative 20 plus 4 is negative 16. So remember, it has to add to the bottom and multiply to the top. So this does factor, and in order to factor this, we're going to split the negative 16 here into the 4 and the negative 20. So it's going to break into 4x and negative 20x. And then we're going to bring down the negative 16 here, bring down the 5x squared, knowing that this is a positive 4. So this will be 5x squared plus 4x on that left side. So now we have two sides. We're going to pair them up and factor by grouping, by placing them in parentheses. Then you're going to pull from each parentheses, each group. So I can only pull out an x from that first group. So I'm going to pull out an x, or factor it out. And then I get x times 5x. I got 1x left over, plus I got no more x's for the 4 because I pulled that out. Now I see a negative that I can pull out, so I'm going to pull out a negative. And I also can pull out a 4 because I can pull out a 4 from 20 and a 4 from 16. So I'm going to pull out a 4 with a negative. And negative 4 goes into negative 25 times. Don't forget that x. Negative 4 goes into negative 16, positive 4 times. Notice that a double negative makes a positive here. Alright, so now these match, so we're going to rewrite them as one factor, and the other factor we're going to just use these two, which is x minus 4. Alright, so now it is completely factored. So that's how you do that using the AC method. You can also use the guessing method in order to solve this. I prefer just being able to solve it every single time, you know, using a methodology rather than just guessing. So this is it factored. So now we know that this is equal to 0 if you bring this down, which means you're going to have to use the zero product property. I'll call it ZPP in order to solve this. Remember that the zero product property states that if you have two things multiplying and it's equal to 0, then each of those factors are equal to 0 separately. So now we send them both to 0 and then we solve. So we're going to have to subtract 4 here. We get negative 4 equals 5x. We're going to divide by 5 on both sides now. So we have here negative 4/5 is x. So I'm just going to rewrite it as x equals negative 4/5. So that's one of our solutions so far. On the right hand side, we're going to add 4. So we have x equals 4. And again, we're going to double check our restrictions. So this is all step 4, by the way. I didn't write it down. So let me go ahead and write it down here. So this is step 4, in case you're interested in the steps. Now step 5, we're going to have to list our restrictions here to our domain. So I'm going to go ahead and write down the original equation just so that we have it as reference. I believe that was an x plus 16. That is correct. Okay, so we have our restrictions here, so we're going to look for our denominators. What can make both denominators equal to 0? So we know that x minus 3 cannot equal to 0, and we know that x plus 16 cannot equal to 0. Otherwise, it wouldn't make any sense to have a 0 on the denominator. So we're going to have to add 3 to both sides. We get x cannot equal to 3. Subtract 16 here, and we get x cannot equal to negative 16. These are our restrictions. And then we're going to match those to our solutions. So notice that none of these solutions match to our restrictions, which means that we are okay to go ahead and say that these two represent our solutions. So we have no extraneous solutions. But we have 2 actual solutions. Alright, go ahead and solve the following problem. Just go ahead and pause the video and we'll go over it. Alright, so let's solve the following problem. 2 over x plus 5 equals 4. So again, you can always rewrite a whole number as a fraction. So that's what we're going to do here. So we got 4 over 1. So I'm just going to go ahead and erase this and just kind of replace it with 4 over 1, and it looks nicer that way. So now if we look at step 1, our LCD is simply going to be x plus 5, since the 1 doesn't really do anything for us. So our LCD is just x plus 5. So step 2, again, we're going to skip step 2 because we're not adding or subtracting fractions here on either side. So then step 3, we'll go ahead and multiply both sides by the LCD, which is x plus 5. In which case the x plus 5 cancels on the left side, but it does not on the right. So we're left with 2 equals 4 times x plus 5. Again, we could ignore that 1 there. It doesn't really do anything for the problem. So we're going to go ahead and distribute the 4. We get 2 equals 4x plus 20. And then we're going to solve. So we have minus 20 on both sides. So negative 18 equals 4x. We're going to divide by 4 on both sides to get our final solution. X equals negative 18 over 4. Make sure to reduce your fraction. So this can be divided by 2 in order to simplify. So it'll be negative 9 over 2 is our final solution. So now we'll have to check this with the restrictions in step 5, of course. So again, I always forget the step 4 here, but that's step 4. And then step 5 is our restrictions. So notice if you look at this denominator, x plus 5, that cannot equal to 0, which means x cannot equal to negative 5, which does not match with this, so this means that this is our solution. We're going to have some problems in which the restriction will match with one of the solutions or more. So we'll get ready for that. Alright, so now we're going to solve something that's a little bit more complicated in the sense that we can't skip step 2. So we won't be able to skip step 2 in this problem because we have, we're adding on that side. So let's go ahead and get started. So for step 1, we're going to have to find the least common denominator here. In which case, so notice that you can't factor x minus 5. You can't factor x minus 3 because it's already as simple as it can be. Now this one you can probably factor. We're going to do an x table for this. We got 15 on top and negative 8 on the bottom. Remember the number without the x on top, the number with the x on bottom, or you can think of it as the c term and the b coefficient. Alright, so now it has to multiply to 15 but add up to negative 8, in which case that would be 5 and 3. They would both have to be negative, however. Two negatives make positive when you multiply, but when you add them, you get negative 8. So this now factors as x minus 5 and x minus 3. So I'm going to go ahead and replace that now. It's going to go ahead and replace that with x minus 5, x plus 3, x minus 5, x minus 3 rather. So that's step 1. Now we're going to have to do the LCD. So notice that the numbers here match, the factors match, which means that we only have to repeat them once. So we have x minus 5 and x minus 3 as our least common denominator. And they both have 1, which means that the most that any of them have is 1. So that's our LCD. So now step 2 involves, now we can't skip step 2 any longer because we're going to have to combine the fractions. So we're going to go ahead and combine these two fractions by basically converting them to the least common denominator. So this first denominator right here is missing an x minus 3. So I'm going to go ahead and multiply by x minus 3 and give it an x minus 3. But in doing so, I have to do the same thing to the top. I can't just do it on the bottom. So there you go. The second fraction is missing an x minus 5 if you look at it. So we're going to give it an x minus 5. And then do the same thing on the top. The third fraction is not missing anything because they match. Okay, so we don't have to do anything to the third fraction. So that is step 2. Step 3 we're going to just combine these two fractions into one. So we have, since they have the same denominator, we can combine them under one denominator. So these two denominators get collapsed into one denominator, and you can simply combine the numerators under the plus sign. So we have here x minus 3. Notice I ignored that invisible 1 there. It's there, but I'm going to ignore it. It doesn't really do anything to the problem. Plus, I have the x times x minus 5. So I combine those two fractions under one denominator. And then I'm just going to rewrite the second fraction here. All right, so we went ahead and combined them. Step 4, or for step 2 rather, I'm sorry. This is actually all step 2 that we're doing here. Now step 3 is going to be multiplying both sides by the least common denominator, which in this case is x minus 5, x minus 3. Which notice that they cancel out. Which leaves us with the step 4 part, which means we'll just have the numerators equal to each other. So we have x minus 3 plus x times x minus 5 equals 2. All right, so now we can go ahead and simplify. So we can notice that we can distribute that. So we have x minus 3. X times x is x squared. We have a 5. So x times negative 5 is negative 5x equals 2. Notice that this is quadratic because we have a squared here. This means that we'll have to put everything to one side, because a quadratic means that you're going to have a 0 on one side if you're going to want to solve it by factoring our quadratic formula. So we're going to combine our like terms here first. We have an x and a negative 5x. It's going to give us a negative 4x. And then I got the x squared here, so I'm going to write that out first. Then I got the negative 4x from these two. And then I'm just going to move down to negative 3. Again, we want the one side to be 0, so I'm going to go ahead and subtract the 2 now. I'm left with x squared minus 4x minus 5 equals 0, which we can factor using the x table. Remember that the c term goes on the top, the b term on the bottom. So two numbers that multiply to negative 5 but add up to negative 4, that would be negative 5 and positive 1. So we can factor this into x minus 5 and x plus 1 equals 0. And we'll have to use the zero product property to set each of these to 0. So x minus 5 equals 0 and x plus 1 equals 0. We'll solve them by adding, here we'll add 5 on both sides. Subtract 1 on both sides for the right side. And we got our solutions here. Again, we're going to double check to make sure that we have restrictions that do not match our solutions. Okay, so let's check those restrictions out. So we're going to go ahead and write down the original equation. We had 1 over x minus 5 plus x over x minus 3 equals 2 over x minus 5, x minus 3. Notice I just left this as factored because it makes it easier. So since these repeat, we only have to do it for these two. So we're going to say, what makes x minus 5 equal to 0? Well, that would be x. This cannot equal to 0, by the way, because that's our denominator, right? So that means that x cannot be equal to 5. And then this cannot equal to 0 at all, which means x cannot be 3. So those are restrictions. Now notice that this restriction here matches this guy right here, which means that we have an extraneous solution, which means this cannot be a solution. So we have here one extraneous solution. So this right here is an extraneous solution, which means it's not an actual solution to the problem at hand, which means the only solution is x equals -1. So this is an example of extraneous solutions singling out other solutions. Let's go ahead and check out the next problem before we do any practice problems for you guys. So again, this one looks a little different, but notice that there's a denominator of 1 here. So it's really the same step, it's just converting that to a fraction. So step 1, find the LCD. Here the LCD is quite simple, you don't have to factor anything. These are already factored as is. So, and they have the same denominator, x minus 2 and 1. So the least common denominator is simply going to be x minus 2 and times 1, but the 1 doesn't do anything. So step 2, we're going to combine the two fractions, which means that they'll need to have the same denominator. So notice that this is missing an x minus 2, so I'm going to give it an x minus 2, and I'm going to do the same thing on the top. So now they have the same denominator. So I'm going to go ahead and combine them now. So the left side is going to stay the same. This is going to be 7x minus 2 over that. These have the same denominator, so I can go ahead and combine them under one denominator now. And I'm left with the two numerators combined on top. This plus 10. So now I have the denominators matching. So that is officially the end of step 2. Step 3, I'm going to multiply both sides by the least common denominator, which in this case is x minus 2. You guys may have heard you can also cross multiply. Really, you know, it's the same process. I mean, you still are going to be left with the same answer, but I wanted my students to practice adding fractions together. So this is how we do it. So we're going to go ahead and subtract, cancel out the x minus 2's on both sides. So we have 5x equals, now we have 7 times x is 7x, 7 times -2 is -14, plus 10. Then we're going to solve. Now notice that this is going to be -4. This is officially step 4, by the way, when we're solving. So now we're going to subtract the 7x on both sides to kind of move it over. Divide by -2. And we're left with x equaling positive 2 so far. And I say so far because we gotta check step 5. So if you notice, if we look at the denominators here, x minus 2, they're both the same. The 1 doesn't really do anything to the problem for restrictions, so we're going to ignore that. So the only thing we have to be concerned with is that x minus 2 cannot be 0, which means x cannot equal to 2, which notice that that matches with this, which means that this is not a solution. This is actually an extraneous solution. Which in this case means we have no solution to this problem, unfortunately. So there's an example where you have the extraneous solution canceling out all the solutions that you have, leaving you with no solution. Let's look at another one. Let's look at this one. So this one, you're going to do the same deal. Step 1, find the least common denominator. This is already factored. This is already factored, it's just x. This one you can pull out an x because they have an x in common. So we're going to go ahead and pull out the x there. If you pull out an x, well, you're left with x times 3x is 3x squared, minus, and then you have x times 1 is x. So we're going to get rid of this now and replace it with that. Notice that x and 3x minus 1 match, so our LCD is simply x times 3x minus 1 because they end up matching and having the same thing on each side, and they both have only one of each. So step 2 now is combining the fractions on the left side. Since they are subtracting, we're going to have to combine them. So notice that this first fraction is missing an x. So we're going to go ahead and multiply by x in order to give it that. Do the same thing on the top. And notice the second fraction is missing in 3x minus 1. So we're going to go ahead and do that, give it to that. So we have 3x minus 1. Do the same thing on the top. Notice that the third fraction is exactly the same, the denominator, so we don't have to do anything to that fraction. So far we can combine these two fractions, these two denominators into one denominator because they're the same. And now we can combine these two numerators. So I have this first numerator minus this second numerator. So I have x times x plus 2 minus, and then I'm going to ignore this 1. That 1 doesn't really do anything to the problem, so I'm just going to ignore it and just write out the 3x minus 1, the red part. So now I have equals the right side, 3x minus 3 over x times 3x minus 1. So that is the end of step 2. Now step 3, I'm going to multiply both sides by the least common denominator, which is x times 3x minus 1. So now notice that cancels. I got to do the same thing on the other side as well. And now we're left with just the numerators. X times x plus 2 minus parentheses 3x minus 1 equals 3x minus 3. So just the numerators are equal. I'm going to go ahead and distribute this. This is now step 4 where we're going to simplify. So we have x squared plus 2x, and then for this we got a negative 3x, and then negative negative 1, which is a positive 1, equals 3x minus 3. Notice that this is quadratic because of that squared. Therefore, we're going to have to move everything to one side so that one side is equal to 0. Now these two become negative x, so I have x squared minus x plus 1. We're going to move the 3x over by subtracting it and canceling it out. Do the same thing on the other side. We're going to get rid of this this negative 3 by adding it so that they cancel, making sure to do the same thing on the other side. So we have x squared, bring that down. We have an invisible negative 1 there, which means these two give us negative 4x plus 4 equals 0. We're going to see if this factors using an x table. So we got 4 on top, negative 4 on the bottom. So remember, it has to multiply 4 but add up to negative 4, which would be negative 2 and negative 2. Which factors to x minus 2 times x minus 2 equals 0. Remember, once you factor and it's equal to 0, you use the zero product property. And notice that there are repeats, which means we only have to write this once. So we have x minus 2 equals 0, which means that x has to equal 2. So far, because we got to check step 5. So we're going to go ahead and check step 5 now. We're going to look at our denominators here. Now notice our denominators are in our original problem. I'm going to go back to our original real quick. Oh, actually this was our original. We had 3x minus 1 and we had x, and we have the same thing on the right side because it's the same as those other two. So we're going to just look at our denominators. So we know that 3x minus 1 cannot be 0, and we know that x cannot be 0, just looking at those two denominators. This one's already obvious, x cannot be 0. The other one we have to solve, so we're going to add 1 on both sides, then divide by 3. So x cannot be 1/3. Which, notice, none of these restrictions match up with the solution that we have, which means that this is our final solution, x equals 2. All right, go ahead and try the following problems, and then we'll talk about them in just a little bit. All right, let's take a look at the first one. So again, we're going to find the common denominator. So notice that this is already factored, this is already factored, there's nothing else you could do with, and this one you can actually do that one out. So we're going to do this up here. So we're going to do an x table, so 15 on top and -8 on the bottom. So two numbers that multiply to 15 add up to -8. That would be -5 and -3. So we're going to cancel this out. We're going to call it x minus 5, x minus 3. So then for step 1, when we do our LCD, this is going to equal, well, we have a 2, so I'm going to give it a 2. We have an x minus 3. Notice we have a repeat x minus 3 there, so I'm not going to repeat that. And we have an x minus 5. So we're going to put those together, and that is my least common denominator. So step 2, we're going to convert each of these to the least common denominator, the denominators I mean. So notice that this 2 is missing an x minus 3 and an x minus 5. So I'm going to go ahead and give that over to it. And do the same thing on the top. Notice that this second fraction is missing a 2 and an x minus 5. So I'm going to go ahead and give that to it, 2 there, and x minus 5 here. Do the same thing on the top. And the second fraction, or the third fraction, is only missing a 2. So I'm going to go ahead and give it a 2. I'm going to do it over here, times that by 2, and then times this by 2. So now we're going to notice that all of these two denominators are the same, so is the right one. So we're going to combine that under one denominator. Again, it doesn't matter the order in which you put the factors. I simply like to write the 2 first, the number first, and then the other 2 factors after it. So now we have this numerator plus this whole numerator. We're going to combine it under one numerator. And then we have equals the other numerator, or the other fraction. Alright, so that is officially the end of step 2. We're going to do step 3, which is multiply both sides by the least common denominator, which in this case is 2 times x minus 5, x minus 3. If I do that, then the x minus 3's cancel, x minus 5's cancel, and the 2's cancel. And that's because one is on top, one is on bottom. And so when you divide them, 2 divided by 2 is 1, which means it cancels. X minus 5 divided by x minus 5 cancels. X minus 3 divided by x minus 3 cancels. One on top, one on bottom. It's called cross-canceling. So step 4, we have the two numerators equal to each other. I'm just going to go ahead and call this 12, 6 times 2. I'm going to go ahead and distribute the 3 into here as well, just to save a little bit of time. I'm going to call this 4x, because 2 times 2. So if I bring this down to step 4, I get 3 times x is 3x, 3 times -3 is -9, and then I got x minus 5 there, plus 12 times x minus 5 equals 4x on the right side. Now we're going to have to distribute this, and we're going to have to FOIL the left side. So we got first, outer, inner, last. So first is 3x times x, just 3x squared. Outer, 3x times negative 5 is negative 15x. Inner is negative 9 times x, negative 9x. Last, negative 9 times negative 5, positive 45. Then we're going to have to distribute it 12. 12 times x is 12x. 12 times negative 5 is negative 60. Bring down the 4x on the right side. So we have nothing to do with the 3x squared, so I'm just going to rewrite that. We can combine the negative 15 and the negative 9x. That's negative 24x. Negative 24x plus 12x is negative 12x. That goes away. You can combine the 45 and the negative 60. That gives us negative 15. That goes away. Equals 4x. Now we're going to go ahead and subtract 4x on both sides. So we have here 3x squared minus 16x minus 15 equals 0. So now it's a quadratic. And we can use the AC method. But I don't know if that would actually work out, because 3 times negative 15 is negative 45. And then we're going to have to figure out negative 16 on the bottom. Two numbers that multiply to negative 45 but add up to negative 16. 9 and 5 would be pretty close. 3 and 15 would also be pretty close. So I'm not sure that there's anything that we can do for this. So we're going to go ahead and just use the quadratic formula to solve this. So if we use the quadratic formula, we got negative b plus or minus b square root of b squared minus 4ac over 2a. And we'll call this, this is a, this is b, this is c. So we have negative, b is negative 16. So you got two negatives, which make a positive, plus or minus. B is negative 16. Minus 4 times a is 3. C is negative 15 over 2 times 3. So we're going to go ahead and have to plug and chug here, do the calculations. So 16 squared is 256. Negative 4 times 3 is negative 12. Negative 12 times negative 15 is positive 180 over 2 times 3 is 6. 256 plus 180 is 436. And you can't do the square root of 436, so we're going to leave it. However, we're going to break down the 436. We can break it down into its factors. Turns out we can divide by 4, so this breaks into 4 and 109. And then we know that the square root of 4 is 2, and we cannot do the square root of 109. So this is equal to 2. So we have here 16 plus or minus 2 times square root of 109 over 6. Then notice that we're going to have to reduce this fraction because we have a 6 on the bottom and we have 16 and 2 on top. So what we're going to do is we're going to pull out what they have in common. Well, these have a 2 in common. So we're going to go ahead and pull out a 2 from the top. So 2 goes in the 16 8 times. 2 goes in the 2 once with a square root of 109 next to it over 6. We can reduce this fraction now. Notice that we got 2 over 6 here. So we can reduce that. We can divide top and bottom by 2 to reduce. And this is 8 plus or minus square root of 109 over 3. So we got two solutions here. Again, even though I don't think it'll match at all, the restrictions is still important nevertheless to actually do the restrictions. So the restrictions here, if you look at the original denominator or denominators, we have x minus 3, a 2, the 2 doesn't really do anything, and we have x minus 5, x minus 3. So we do know that x minus 3 cannot be 0, and we do know x minus 5 cannot be 0. So x cannot be 3 or 5, which of course, as we mentioned, does not match this. So we're good. We got our two solutions. So our two solutions are 8 plus that and 8 minus that. Final answer here. Again, we're not going to really do problems like this very often where you cannot factor them, but I just wanted to provide one example in which you used a quadratic formula just in case you get a problem like that. However, the rest of the problems should be factorable problems. But I just wanted to give you at least one. So let's look at this one. This one should be factorable, should work out nicely. We have here x minus 3, x plus 3. Those cannot be factored. This can actually be factored. So we're going to set up an x table for this. Negative 9 on top and 0 on the bottom because there's no middle term here. In which case that would be 3 and negative 3. 3 times negative 3 is negative 9. They also add up to 0. So we're going to replace this. X plus 3, x minus 3. So step 1, we have an x minus 3, and we have an x plus 3. And they repeat. So we're just going to write them out once. That's our LCD. Now step 2, we are going to convert them to the LCD. So notice that this is missing an x plus 3. Do the same thing on the top. The second fraction is missing an x minus 3. Do the same thing on top. The third fraction is not missing anything, so don't do anything. Combine these two fractions into one, these two denominators. You're going to combine these numerators with an addition sign in between. Equals the right side. Now step 3 is going to be multiplying both sides by the LCD, which in this case is the same for both. So they cancel on both sides. So now we have the numerators equal to each other. So now we're officially in step 4. So we'll have to distribute. So we have x squared plus 3x plus 2x squared minus 6x equals 18. Noticing that this is quadratic, we can combine these like terms. We can combine the x squareds into 3x squared. The 3x and the negative 6x can be combined to be negative 3x. And then we have equals 18. So we can go ahead and, we're going to go ahead and move the 18 over. So that we have 0 on one side, which is what we want in order to factor. So instead of doing the AC method, I'm going to propose just going ahead and dividing by 3 or pulling out a 3 on from the left side. So we're going to pull out a 3, leaving us with just x squared, leaving us with just a minus x, and then 3 goes into 18 6 times. And therefore we can ignore this 3 and factor this. So we're going to do negative 6 on top and negative 1 on bottom. Again, there's an invisible negative 1 here. So that means that this would be negative 3 and 2. So they multiply to negative 6 but add to negative 1. So now we have the 3 here. Again, we're going to ignore it. I'm going to write it down, but I'm going to ignore it for the solution. We write this as x minus 3, using those two numbers, of course, and x plus that 2 equals 0. Use the ZPP, but ignoring this 3 here, it doesn't do anything. X minus 3 equals 0, x plus 2 equals 0. Add the 3 to both sides, and then subtract the 2 for that right side. So x is 3 and negative 2. So then we're going to, that's step 4. I always forget to write out the step. Well, I did write it out this time. And then step 5 is going to be looking at your restrictions. So if we look at the original, the denominators are x minus 3 and x plus 3. So we know that x minus 3 cannot be 0, and x plus 3 cannot be 0. And if we solve this, well, x cannot be 3. If we solve this, well, x cannot be negative 3. Notice that this matches up with this, which means that we have an extraneous solution here. So this cannot be a solution. Therefore, the final solution is x equals negative 2. All right, that's it for the video, guys. I hope you found this useful, and I'll see you in the next one.